Uh, Hello, sir. Uh, our group is group 2. Our topic today is about hydroelectric power. Our group consists of Suing, Chen Yain, Pepe, me, Kartik, and Ashraf.
Hydroelectric power is the most common renewable energy source used to generate electricity. It's the basic electrical energy that has been generated using natural forces such as gravity or falling water. It's the most popular green energy source because the process doesn't use any of the more common fossil fuels such as oil, coal, or natural gas.
Today we would like to introduce two popular dams at the east and the west. They are the Hoover Dam, and from the US in between Nevada and Arizona states. Another is Three Gorges Dam from China, Hubei. Yep, right. Hoover Dam was older and built after 1936. It took 5 years to build, whereas Three Gorges Dam was built last decade after 2003 and took 9 years of time. Hoover Dam used to be one of the biggest dam in the world in last century. It's now the 60th largest in the world. It produces 2080 of capacity. Three Gorges Dam, it is the largest dam in the world, having 22,500 megawatts of capacity. Both of them are supplied by Three Gorges Reservoir and Lake Met respectively. Three Gorges Dam has total 32 various sizes of turbines as compared to Hoover Dam with total 18 turbines. The maximum length of Three Gorges Dam is 600 kilometers. It is 3.3 times longer than Hoover Dam. The main construction of the dam involves reservoir, splitway, intake towers, penstocks, powerhouse with turbines and generators. Followed by river at the output and electrical. Why did you interrupt?
Hey.
Yo.
The main construction of the dam involves reservoir, splitway, intake towers, penstocks, powerhouse for turbines and generators, followed by river at the output and electrical power line distribution by the users. Dam construction at first considering hydrologic inflows, downstream outflows, requirements and external disturbance that may affect operations. Coupled with in managing the safe discharge of inflows and the control of water retention for productive uses. Design of penstocks, turbine sizes are important to produce the substantial power supply with highest effectiveness and efficiently. Building a strong spillway is also one of the biggest challenge. A spillway which can sustain over a century damage of dam spillways of cavity information is not negligible and need to be maintained over the years.
How is power generated? Hydraulic turbine converts the energy of flowing water into mechanical energy. Hydroelectric generator convert this mechanical energy to electricity. The operation of a generator is based on the principle discovered by Faraday. He found that when a magnet is moved past a conductor, it causes electricity to flow, which is Faraday's law we learned inside the ACTA class. In a large generator, electromagnets are made by circulating direct current through loops of wire wound around stacks of magnetic steel lamination. These are called fuse poles and are mounted on the prime perimeter of the rotor. The rotor is attached to the turbine shaft and rotates at the fixed speed. When the rotor turns, it causes the fuse poles, the electromagnets, to move the conductors mounted in the stator. This causes electricity to flow and voltage to dissipate at the generator output terminals. Electric power distribution is the final stage in delivery of electrical power. It carries electricity from the system to individual consumers through the transmission line. Customers demanding a much larger amount of power, 26 to 36 kilovolt, may be connected directly to the main distribution level or substation. Distribution substation connect to the transmission system and lower the transmission voltage to medium voltage between 4 kV and 13 kV with the use of transformers. Primary distribution lines carry this medium voltage power to distribute transformer located near the customer premise. Often, several customers are supplied from one transformer to secondary distribution line. Commercial and residential customers are connected to the secondary distribution line through the service job.
The advantage of building hydro power station. If electricity is not needed, the sluice gates can be shut, stopping electricity generation. The water can be saved for use another time when electricity demand is high. Dams are designed to last many decades, and so it can contribute to generation of electricity for many years. The larger dam can become tourism attractions in their own right. The lake's water can be used for irrigation purpose. Moreover, energy also can be stored until needed when the water is released from to produce electricity. Moreover, we cannot produce greenhouse gas and pollute our earth. We it start work.
Okay. The impact dams have on our environment. Landslides. Erosion in the reservoir induced by rising water cause frequent major landslides. It alters the entire ecosystem because freshwater fish are especially affected by dams due to changes in water temperature and flow regime. Many other fish are hurt in turbine blades of the hydroelectric plants as well. It causes flooding of land because the flow is slower above the dam. Much of the sediment will now settle there instead of flowing downstream, and there will be less sediment downstream. The temperature of the water. The water of the deep reservoir in temperature climates typically saturates with a large volume of cold, oxygen-poor water in the hypolymian hypol hypolymian I cannot hypolymian differences between surface water and bottom water temperatures up to 16.7 degrees Celsius. These are the links to all our slides. You can click